totally. But I'm back. I'm back. It says given the equation, right? X squared plus m is equal to 0, where m is between -5 and 3. Write down two values of m for which the roots of the equation are unequal and rational, unequal and irrational, and then here non-real. Okay, yeah. So for this question, what are your thoughts?
I mean, are we going to use the entire theater? How?
Are we going to use the what?
Theater, oh my goodness, that sounds so old. Are we going to, are we going to use, isn't it theater? It's not theater, no?
Theta. We're talking about delta.
I'm so sorry. Delta, yes, I'm going to use delta. And use
Yeah,
the
we kind of
delta
are.
is bigger than 0.
Yeah, so for something that's unequal and rational, we need to work out where delta is bigger than 0. And we need to formulate an expression that has a perfect square. So formulate an expression, or rather, let's just think of a perfect square. Think of a perfect square. Because remember, we've mentioned anything to do with rational or whatever, you always think of a perfect square. Do you remember that?
Yes.
Pardon?
Oh, I said yes.
Ooh, think of a perfect square. So, what we have here, right? I mean, the fortunate thing is, let's see, given this equation where m is between this and that, write down the two values for which blah, blah, blah. So the only issue is between -5 and 3, right? I mean, like, you obviously have quite a lot of numbers. And the problem now is we would not only want to be thinking of the integers like your -4s and your -3s and your 1, 2s and your 0s. We would not only want to be thinking of that only. You see, so that's why this question, we kind of need to go through the whole process. So in terms of this equation, right, like our a value is just a 1, our b value is like a 0 because it's not there, and then our c value is the m there. So we're working out where delta is bigger than 0, right? So we're working out where b squared minus 4ac is bigger than 0, meaning that b is a 0, a is a m, I mean, a is a 1, m is a c. So this one is kind of weird because it's like, oh my goodness. I mean, it's giving us an answer, yes, but what is it saying? So it's like -4m bigger than 0. And then if you divide by a negative here, m is smaller than 0. So we have to choose a value for m that is smaller than 0. But the issue is we're seeing here m has to be between, they told us that m has to be between -5 and 3. So it's like -5 here, and then there's 3 over there. 3, like that. You see -5 and there's like 3. So our answer here is saying that for us to have unequal roots first, before we deal with the rational part, for us to have unequal roots, our value of n needs to be smaller than 0, of which values of m, yeah, our value of m needs to be smaller than 0, of which values of m that are going to be smaller than 0, that will also like still fit our what you call our restriction here, is specific values like, let's say here, specific values like you know, -1, -2, -3, -4, and the like. So the idea is for this to be unequal and rational, remember we said we need to think of a perfect square. So we need to think of a way that this thing here can be some kind of a perfect square, you know? And the one way that can happen is if m is a -4. You see, because from these options here, right? I mean, like one way or the other, if x squared, if we have a -4 here, right, equal to 0, what you have on the left here is something that can be written as, well, this is low-key, but then wait, hold on, perfect square, difference of two squares, that's definitely not the same thing. Given the equation this, where m is between that, oh, write down two values. So we need two answers, like two values of m for which the roots of the solution are rational and unequal. Rational and unequal. Well, if we were to test out -4, let's see what kind of a solution we would get. You'd have here x is equal to 4. Square root both sides, you'd have plus or minus 2. Of which this is both, these two answers are not equal. And they are both rational. So -4 would work. You see?
Yes.
Yeah. So let's test out another answer, another value that would give us two answers that are not equal and rational. And the only one that works, you see, it's going to be a -1, because that's the only one that somewhat can represent a perfect square. Because you see here, 4 is already a square number. That's why it can work out. 1 is a square number. That's why this -1 is also going to work out. Because when the 1 goes over to the other side, then you square root both sides, you're going to have plus or minus 1. You see, so x is equal to -1 or x is equal to 1. You see, of which these are two values that are not equal and they're also rational. So here we can say, therefore, m is equal to -4 or m is equal to -1. Because this answer up here just gave us an idea of which values for m we should consider in this restriction that were given up here. So in this restriction, we should consider values for m that are smaller than 0. Amongst the values of m that are smaller than 0, the ones that will cause us to have roots that are not equal and roots that are rational, we are clearly seeing here it was just -1 and -4, like that. You see?
Please repeat the. Oh no, never mind. It's fine. It's fine.
Fantastic. So for the next one, where it's like unequal and irrational, then basically half the process is the same up until here. You see, because this portion will give us an idea of like what your value of m needs to be for your solutions to be unequal. So this is telling us that obviously as long as m is below 0, our solutions are going to be unequal. So with that being said, yeah.
Well, I was about to say, isn't going to be delta is smaller than 0.
Well, yeah, so that's what I'm saying. For B, for number 2, right? The first portion here is exactly going to be the same until we end up here. So for us to now work out where where those solutions are going to be irrational, then we obviously need to think of the opposite of this, which is just going to be these two answers here, the -2 and the -3, because the -2, if you throw that there and you like solve for x, you're going to get two answers that are both not equal and both not rational. If you use a -3 there, you're also going to eventually get two solutions that are not rational and not equal. So for question number 2, m is equal to -3 or m is equal to -2.
Okay.
Yeah. So that deals with 1 and 2. For 3, where it says non-real, we already know that for anything that's non-real, what do we have to do?
the delta is smaller than 0. That's when it's non-real.
Yep,
Mm.
delta is smaller than 0. So we have to work out where b squared minus 4ac is smaller than 0. So the b is going to be, we saw here b is just a 0, and then a is a 1. b is a 0, a is a
Okay,
1,
let's
c is a m. And then here we're going to have minus 4m smaller than 0. And then here, same issue. We're going to divide both sides by -4. And then m is bigger than 0. You see, so we're seeing that for our roots to be non-real, our value of m just needs to be bigger than 0. So we can test it out, right? If m is bigger than 0, it's obviously definitely going to give us roots that don't exist. Because, for example, if x squared, if m is bigger than 0, you can think of, let's say, even +1. If you try to work this out, it won't work out because you'll have a -1 there. And then when you square root both sides, nothing is going to come out, you see. Yeah. That's that. Anyways, let me just show here what has happened. You see here we had square rooted one side, we had square rooted the other. Same here, you see we had just put this under square root, and we also had just put this under square root. But then here we cannot because it's negative, you see. So that's why we will have non-real roots. So does this make sense?
Yes.
Perfect. Perfect. So what's the scope for